Very good. So let us come to here. As we know, in last class we studied what is latent heat and as well as the types of latent heat. So latent heat is two types. What is the two types, guys? One is what?
Latent heat of fusion.
Latent heat of fusion. That is what? What do you mean by fusion, Danishka? What do you mean by fusion? Another type of fusion. Melting. Other what Danishka don't know. Latent heat of fusion. So fusion also we can call it as melting. So converting what to what? Vocal from solid to liquid state. Next one. So next one is what? Latent heat of vaporization. Understanding? So vaporization means also we can call it as what, guys? Vaporization. Yeah, vaporization also we can call it as boiling. So which is converting which state to which state, guys? Liquid state to
Gas.
Yes.
So all by increasing heat or decreasing heat, solid to liquid and liquid to gas by increasing heat. Yes or no? So that is what will happen. Now at a particular temperature where understand the energy whatever we are providing, it is not help to increase the rise in temperature, which will help in breaking the bonds of the substances. That is what we used to call as. What is that heat energy we used to call? That energy is called as
Latent heat.
latent heat. So during that breaking of bonds, temperature of the substance does not rise, but what it will rise, guys? What it will rise? The energy which is supplying during that time, it will break the bonds and the state of matter will change. Is it yes or no? Solid will converting into liquid or liquid will converting into what, guys? Liquid is converting into what?
Yes.
That is what will happen. So let us discuss today's class. We are going to study how this latent heat of fusion means. Latent heat of fusion means converting from which state to which state, Harish? Converting solid state to liquid state. Understand? So same way later we will study next one. That is what? Latent heat of vaporization. That is what? Liquid state to gaseous state. Okay, shall we start now, everyone? Now, if you take here, please all of you keep heading. Latent heat of fusion, that is what? Solid to liquid change. Latent heat of fusion, please all of you keep heading. Latent heat of fusion, bracket, what you have to write, Arun Kailash? Latent heat of fusion, bracket you can write. Solid to what? Solid to liquid change. Okay. Now I think Arun Kailash, you finished all the pending things. Is it anything true? Are you not at Danishkar? You also all the pending things completed. Tomorrow offline class I'll check your class also. Okay. So that is what. So this is what. Let us discuss what is latent heat of fusion and all. Now, as we all know, if you'll observe here, latent heat of fusion can be studied by performing some experiment. So let us take that experiment and how it will be the place. So solid to liquid means, as I told you, if we're having in our home ice cubes, then you can start that experiment also. So please all of you take, if you're having, you can take. If it does not have also, it's no need. So if you'll observe in our laboratory, so see that figure and notice it. This is what the experimental setup for our experiment. So we start now, everyone. So iron stand, we can say. This is what iron stand, STAND. Okay. Now if you see, guys, everyone here. So this is what the experimental setup we have to do. What is this called as? You all people know that. What is this called as?
Thermometer.
Understand? Now, you will see everyone here. I have been taken some crushed ice in a beaker and suspended a thermometer in it. So, if you note that the temperature of ice, it is found to be around. How much the temperature, guys? You see, observe in the picture and tell me what is the temperature here.
0 degrees Celsius.
What is the temperature? 0 degrees Celsius. So as we know, temperature is 0 degrees Celsius. So that is what we used to call as melting point of water, or also we can call it as what? Freezing point of water. Yes or no, guys? Less than that, it will freeze. More than that, it will melt. Yes or no, Harish? Danishka?
Yes, sir.
Yes, everyone. So that is what. So what is the temperature? Everyone note it down. What is the temperature you are seeing here? What is the temperature you are seeing? 0 degrees Celsius. Now you can see we can heat the ice gently by using a small flame of burner. So I am providing heat now. Can you able to see guys here? With the help of small
Yes, sir.
flame of burner, if you'll notice it, then what will happen guys here? We keep on recording, you can see. Now we are heating the ice very gently, continuously, you can see. The ice will start melting to form what guys? Ice will start melting to form what? This ice
Gas.
slowly
Liquid.
converting into gas or water. It will be start melting
Water.
and it will be forming into water. That is what liquid state we can say. Now, if you'll notice it, when we keep on recording the temperature of melting ice, melting, then thermometer every 1 minute I am checking. So if you'll see, as more heat is given, more ice will melt to form water. But the thermometer reading remains at what temperature, guys? Remains at what temperature? Remains at what temperature, guys? Remains at
0 degrees Celsius.
so every 1 minute you check the temperature of the thermometer. Still the reading is showing how much, Danishka? Still the reading is showing 0 degrees Celsius only. So at that temperature, whatever the heat is providing, what is happening, guys? Anybody can tell me why the temperature is not increasing? Anyone, please? Because that heat energy is useful to what purpose? That heat energy is useful to some other purpose. What is that purpose I'm asking?
To break the bonds.
To break the bonds between whom? Between ice.
Between the particles.
Particles of whom, guys? Particles of
Ice, sir.
ice. That is what will happen. Now, when we can observe the rise in temperature, anybody can tell me? Arun Kailash, once ice will completely melt, do you understanding? Once fully liquid will form, then what will happen? Then we can notice it rise in temperature. So every 1 minute, if you are note down the reading here, remains even a little of ice in a beaker, the temperature does not rise. Do you understand, Arun Kailash, what I'm saying? So small piece of iron is here, small piece of ice is remains still, then still the temperature will never rise. Do you understand, everybody? Please try to communicate here. So as long as remains even a little of ice in the beaker, the temperature does not rise, remains at constant at what temperature, guys? Remains at constant at 0 degrees Celsius. Understand? Now, so this shows that what it is showing, there is no rise in temperature during what action, guys? During melting of ice. Yes or no, guys? So at a particular temperature only complete melting will take place. So from that we can say one conclusion: there is no rise in temperature during the melting of ice. So we can say no rising temperature. Are you clear? Ready? Rising temperature.
Yes, sir.
during melting of ice. So please all of you note it down. Why, guys? That energy is useful for what? But still we are providing heat energy. We are providing still heat energy. So but that energy is useful for what? That energy is useful to
break the ice.
Break the force of attraction present between the particles, and they will be moving for each other. Yes or no? Gokul, Danishka?
Yes, sir.
That is why we can say only when all the ice has melted that temperature of water, then it will start rising the temperature, further heating. So once this fully ice will be converting into liquid, then still when we are heating, what will happen, guys? Then what will happen? Then we can see the rise in temperature. Understand, everyone? Every substance is like that only. But is it every substance is having same melting point or different melting points?
Different melting points.
That is what remember. Okay. Now the heat which is going into the ice but not increasing the temperature is the energy required to change what, guys? Required to change the state of ice from solid to which state? Solid to liquid. So that is what known as latent heat of fusion. What is to call, guys? That is what we used to call as latent heat of fusion. But still, see, no rise in temperature, but still we are providing energy or not? Yes, please respond. That is what called as latent heat of understanding, latent heat of energy, or we can latent heat of fusion of ice. We are melting as ice. That is what we can say. Latent heat of fusion we can say. So that is what it is, everyone. Have you understand? So once it is fully converting into liquid, then what will happen, guys? Then we can see
The temperature will rise.
temperature. Clear? Yes. Yes, please
Sir, in
respond.
liquid state, it will rise only up to 100, no, sir.
Yeah,
After that,
up to 100. Once 100 will takes place, then completely it will be keep on 100 and above 100, little bit like 102, 103. Still, it is fully converting into gaseous state. Understand, Hari? Then only it will be increased. Okay, so that is what you have to remember. So this is what is melting. So during melting, whatever the heat energy we are providing, it is used to involving in change of state of matter. So that heat only we used to called as what, guys? Latent heat of fusion. Okay, so that is what. So please all of you write the definition. Latent heat, right? The latent heat of fusion, the latent heat of fusion of a solid, the latent heat of fusion of a solid is the quantity of heat, First of all, let me say, even class 8th I taught you what is the unit of energy. Anybody can tell me? Unit of energy, any energy. Chocolate, if you read, you can find it on the surface. Chocolate, that is what joules we can say. What is the unit of energy, guys? Joules. Understanding? All calories also we can say, but calories, food items we can use. So joules is the common unit of energy, any energy. Do you understand, Harish? Ready? Please note it down. Joule.
Yes, sir.
Joule, joule is the unit of energy. Those who don't know, please note it down. Okay, physics it will come. So what do you mean by latent heat of fusion? So all of you write the definition. Latent heat of fusion. Latent heat of fusion. Can I say?
Yes, sir.
Yeah. Now, right. The latent heat of fusion. Latent heat of fusion, or also we can call it as what? Bracket. Melting we can say. What we can say? Melting. Understand? Latent heat of fusion of a solid is the quantity of heat is the quantity of heat in which units, guys? Is the quantity of heat in joules required to convert required to convert 1 kilogram of the solid, 1 kilogram of the solid required to convert 1 kilogram of the solid at melting point to liquid. At 1 kg of the solid at melting point, bracket you can keep, to liquid without any change in temperature. That is very, very important. Yes or no? Without any change in temperature is called as what? Without any change in temperature is called as what?
Latent heat.
Latent heat of, not latent heat of fusion or latent heat of melting. Arun Kailash, please try to communicate and answer my questions. So that is what. So this is what latent heat of fusion we can say. So whatever heat energy required to melt how much substance, guys? Only 1 kg of substance. Understand? So that is what we used to call as latent heat of fusion. So that is what you can take units of latent heat of energy. You can see what is that units. Can anybody tell me how we can measure? Joule. Okay. Joule per how many kilogram? Joule per
1 kilogram.
Joule per how many kilogram, guys?
1 kilogram.
Per 1 kilogram. That is what we used to call as latent heat of fusion. Is it okay, guys? Joule per kg. Understand? Joule means what? Heat energy required. Simply, if I want to say, Danishka, remember, the heat energy required to melt the 1 kg of solid substance is called as latent heat of fusion. Is it okay, guys? The heat energy required to melt the how many kg of energy? How many kg substance, guys? 1 kg of substance. Understanding? Without changing the temperature is known as latent heat of fusion, or we can say latent heat of melting. Are you clear, everybody? Please respond.
Yes, sir.
Understand?
Yes, sir.
If you take water, experiments I am saying, by experiments I am saying, understand, it's required 3.34 into 10 power 5 joules. How much, guys? 3.34 into 10 power 5 joules per 1 kg of ice. Do you understand? So if you want to convert 1 kg of ice to liquid water, how much energy is required, guys? Liquid water, how much energy is required? 3.34 into 10 power 5 joules. Do you understand, everyone? Please respond. That is what. So we can say, what is the latent heat of fusion of ice? Anyone can tell me? What is the latent heat of fusion of ice? Latent heat of fusion of ice. Latent heat of fusion of ice. How much? Fusion of ice, which is equals how much, guys? 3.34 into 10 power 5 joule per what? Joule per
kg.
joule per kilogram. That is what we can say simply, J per kg. That is what we can say. So that is the latent heat of ice. Is it this latent heat is same for every substance? Latent heat is same for every substance?
No, sir.
No.
No, sir.
Different substance is having different latent heat. So one thing you have to remember, without changing the temperature, that is what you have to remember mainly. Is it okay, guys? Yes,
Yes,
or no?
sir.
Yes, sir.
So we just like solid melts on heating and its temperature remains the same. So now you can see, then important question will arise. Where does that heat energy goes? Where that heat energy goes, guys? Where the heat energy goes? No rise in temperature. So where the heat energy goes? Please respond. The heat energy, if it is heat energy is there, then it will help to rise the temperature. So temperature is remains same. It's not changing. So that heat energy will helpful for what? That is what my question I am asking. Please respond.
Breaking the particles
break
in
the
the
bond.
substance.
The bonds or force of attraction between these particles. Please all of you write. Very, very important question. During latent heat of fusion, where does the heat energy goes? Where does the heat energy goes? That is what the question. Answer. Heat energy is used up in during latent heat of fusion. Okay, fusion. Heat energy is used up in changing the state of heat energy is used up in changing the state of the solid, used up in changing the state of the solid substance from which substance, guys? Solid substance to liquid by overcoming the force of attraction between the particles, by overcoming the force of attraction between the particles. Is it okay, guys?
Yes, sir.
Yes, sir.
So during that time, energy is not going to waste. It is going to be useful to break the bond. Is it okay, guys? So that is what. So
Yes, sir.
we can conclude that at the 0 degree Celsius, what is the energy is required to melt 1 kg of ice? Everybody, what is the required? What is energy? required to melt rice? 3.34 into 10 power 5 joule per kg. Do you understand, everyone? Please respond. Yes?
Yes, sir.
Now, same way, when you are freezing the 1 kg of water, like for example, I'm saying 1 kg of water, if I have been taken, if I'm trying to freeze, then how much energy will release, guys? Freeze means ice. Then how much energy is released? Again, how much energy is released? Heat energy.
3.34
into
3.34 into 10 power 5.
release. Is it understand, everyone? So whatever the energy is required to convert into ice, convert into water, same energy is released during water is converting into ice. Understand? So water is converting into ice. Why heat energy is released? Because it is which state? Liquid to solid state. So it is cooling action or heating action? It is by cooling. So that much amount of heat energy is released. Is it okay, everyone? Have you understand or not? Yes, please.
Yes, sir.
Now,
Yes, sir.
for example, how many of you taken the ice cube into your hand? Please respond. When we hold a piece of ice in our hand, it will feel very cold. Why, guys? Anybody can tell me? Why it is feeling very cold?
Sir,
because
the ice cube will absorb the heat from our hand, sir.
Our body and in our hand, the ice will start melting slowly. So it will take the latent heat from whom, guys? The required heat energy, the required heat from whom?
Body.
Our body. So if once the heat is taken from our body will lose its temperature or it will gain its temperature. It will lost the temperature. Understand? So ice will gain the temperature. So that is what we will feel. So once heat is removed from our body, how we will feel? We will feel cool. Yes or no, guys?
Cool.
Yes, that is what will happen. Understand, everybody?
Yes, sir.
Yes? Please remember, that is what it will happen.
Yes, sir.
So, when a liquid freezes to form solid, the equal amount of heat is given out. So always remember, when it is solid is converting into liquid, whatever the energy taking during liquid is converting into solid, same energy will be came out. Do you understand, everyone? Same energy release.
Yes, sir.
That is what, everyone please kindly remember it. Okay. So this is what latent heat of what we used to call latent heat of fusion, which is converting solid to liquid state. So example also I said, if you want to convert 1 kilogram of ice to water, so what is the energy is required? 3.34 into 10 power 5 joule per 1 kilogram. Is it okay, everyone? That is for what? Ice. Okay. At what temperature? 0 degrees Celsius. Okay. So that is what you have to remember. Is it okay, everybody? Yes. So that is. Understand, Ra?
Yes, sir.
Yes. Next. Say next one. So this is what it's okay. This is what converting latent heat of fusion. Next, second one is what? Latent heat of vaporization. All of you keep reading. Latent heat of vaporization. Latent heat of vaporization. Now completely ice converting into water. Now temperature rises or not, guys? Temperature rises or not? Please respond. Temperature will rises. Yes or no, Harish? Yes. So now you can take the again we'll take the latent heat of vaporization, which is studied. Again we'll follow some other experiment. That is what we will take now. The similar experiment, but now what is in which state? Liquid state. Okay. What is in which state, guys? What is the state of water now? Liquid state. Now what is vaporization? Anybody can tell me? Converting solid to liquid or liquid to gas? Solid to liquid or liquid to gas? It is converting liquid to gas. Now you can able to see this picture. The similar setup which we have been made before, we are going to set up now. But here we are taking completely what? Completely we are taking what? Water, liquid water. Now you can see when we are keep on heating, temperature is rises. Now its temperature what is become? It is equals to how much? It is equals to 100 degrees Celsius. This is what we know. Boiling point of water, which is equals to condensation point. Do you remember, guys? Yes. So now temperature reaches to 100 degrees Celsius. Okay. So that is what where the liquid water will converting into which state? gaseous state. Okay, that is what water vapor we can say, or steam we can say. Now if you notice it, so during the time I'm continuously heating, I'm providing heat. You can notice it, once the temperature reaches to the 100 degrees Celsius, still I am keep on providing heat. Is it further rising temperature? Is it further rises in
No,
temperature?
sir.
No. So by the time you can see even the single drop of water is present inside the beaker. So there is no rise in thermometer reading, because by the time that energy is useful for what purpose, guys? That energy is useful for what purpose?
Breaking the bonds, sir.
Understanding, to overcome the force of attraction which is present in the liquid state. Is it okay, guys? Everyone please respond. That is what you have
Yes,
to
sir.
remember. Now for example, if we'll take water, we are taking water, how much, guys? Water how much it is? 1 liter of water, sorry, 1 kg of water, yes or no? So if we'll take 1 kg of water, understand, if you want to convert it into gas or steam, then we need how much amount of energy, you know, guys? 22.5 into 10 power 5 joule per kilogram. How much, guys? 22.5 into 10 power 5 joules per kilogram. This much amount of energy is needed to convert the liquid water into what? Liquid water into gaseous state. Understand, everyone?
Gaseous.
Gaseous state. That is what it will be happening. So till complete water is converting into gaseous state, we will never observe rise in temperature. So this is only we used to called as what? Anybody can tell me what is this value called as? Latent heat of vaporization of what? Latent heat of vaporization of what? Vaporization of water.
Water.
Vaporization of water, we can say. So is it this value is same for every substance? Is it this value same for every substance? I'm asking.
No, sir.
Arun
No,
Kailas?
sir.
Danishka, it's
No,
not.
sir.
No,
So
sir.
different substance is having
No, sir.
different value. So this value is for what purpose, guys? This
No,
value
sir.
is whom? The latent heat of
The
what?
heat energy, sir.
Latent heat of vaporization of
Liquid to
whom?
gas.
Liquid water. That is what you have to remember. So now please all of you write latent heat of vaporization definition. Definition. The latent heat of vaporization of a liquid, the latent heat of vaporization of a liquid, latent heat of vaporization of a liquid, Arun Kailas, have you understand? Gokul, of a liquid is the quantity of
Yes,
heat.
sir.
Yeah, is the quantity of heat. Arun Kailas only no response. Is the quantity of heat. Quantity of heat in which form, ga? What is the unit of heat? Quantity of heat in joules.
Joules.
Yeah, in joules. Yeah, in joules. Only joules, sorry. Okay, in joules required to convert. Required to convert how much amount of water? Required to convert
1 liter of
kilogram
water.
of the liquid. We should not say water. We have to say liquid because it is not for water, correct? Every substance, yes or no? Convert 1 kilogram of liquid. 1 kilogram of 1
Sir, you have
kilogram.
to give liter, no, sir?
Yeah, no, Reddy, you can take in liquid, no problem. Because liter is not equals to kilogram, okay? So we will take a container. For example,
sir.
for how to take, you may ask me. You will take one container, Reddy. We'll measure in the mass. We'll measure the mass of empty container, okay? Later, we'll pour the water. Understand, Reddy? Then we will take the total mass. Total mass we can measure and we'll subtract this one so that we'll get the 1 kg. Is it okay, Harry? Ready?
Yes, sir.
That is what we can measure. Okay, liquids. You might be thinking, sir, liquids means how we can measure in kilogram. With the help of containers, we can measure. Okay.
Yes, sir.
That is so 1 kilogram of liquid. At what point? Liquid to vapor. At what point? At boiling point. Liquid to vapor or gas. At what point, guys? At
Boiling point.
boiling point. Remember, boiling. Boiling point. At boiling point is known as what? Is known as What is it called?
Latent heat of
Latent heat
boiling,
of
sir.
vaporization. Latent heat of vaporization, or we can say latent heat of boiling. And one more thing, one more point you missed it. Without changing
The temperature.
temperature boiling point, without changing temperature, that is very, very important. Without change in temperature is known as latent heat of vaporization. Is it okay, everybody? Yes, please.
Yes, sir.
Yes, that is what. So please write it. Neatly write it. So what is the example? Example required. What is the example? Latent heat of vaporization of water is how much? Is how much, guys? Latent heat of vaporization of water 22.5 into 10
5
power
into
5
10 power
joules
5
per
joules per
kilogram.
kilogram.
Okay. Same way now here. During the time where the heat energy will goes. That is what my question. Anybody? During the time where the heat energy will goes.
To break the bonds, sir.
To overcome the force of attraction between the particles. So please write it. During the change of state, at boiling point, the heat energy supplied to a liquid, is used up in the state of changing the state of the liquid substance, into what substance, guys? Changing the later state of the
Gaseous.
substance into gaseous substance. By what, Gokul, Arun Kailash, by what? How it will be converted
By
into
boiling.
the solid state? By overcoming the force of attraction between its particles. By overcoming the force of attraction between its particles. Is it okay, everybody? Yes.
Yes,
So
sir.
from that we can say during
sir.
the change of state, is it rise in temperature will be there? No rise in temperature. You understand?
sir.
So that is why you can see. So if you notice it, the boiling water is having maximum temperature 100 degrees Celsius. But once the full water is converting into water vapor, then what is the temperature? More or less steam. Steam or gas, is the temperature is more or less, guys? More. Understand? So always gas is having more temperature than normal things. So this is all about what is latent heat of, what is to say? Latent heat of
Vaporization.
and as well as latent heat of fusion. So both the things, hope you all understand. Any doubt? Yes?
No, sir.
Clear? So the main important thing, where does that energy goes? That is what you have to remember. Clear, everyone? Where does that energy goes? Okay? So that is the important thing. Understand, Hari? Arun Kailash?
Sir,
Yes? Yeah, ask me.
sir, they're just asking where does the energy goes, sir. They're just saying like what it is used for, sir.
Yes?
Sir, they're asking where does the energy go, sir. But we're saying for what it is used, sir. But this answer is correct, sir.
Yes, that is what Harish I'm saying. Suppose, see, you have 100 rupees. You not bought anything. Then where does it goes? You have given to some friend, or you have been misused, or it has been stolen, or it has been lost somewhere. Yes or no, Harish? Same way. That energy here, it is not helping to rise in temperature. Understand, Hari?
Yes, sir.
So that energy is useful for where? That energy is useful to, it is going to lose to break the bonds, to overcome the force of attraction. Do you understand, Hari?
Okay, sir.
That is what the meaning. Is it okay? So that the energy is useful to, it is going to lose that energy to overcome the force of attraction. Understand, Ra?
Yes, sir.
Okay, everyone. Others? Vardhini, Arun Kailash. Okay. So that is what you have to
Understood, sir.
remember it. Now, if you'll take, this is what latent heat of fusion and latent heat of vaporization. Now the next concept which we are going to study, a simple concept which will wind up after this, that is what we used to call it as sublimation. So please all of you keep reading sublimation. Sublimation. Okay, now sublimation means, remember, very important thing, that is what, without forming liquid state. What is that, guys? Without forming liquid state, understanding liquid, directly solid is converting into which state? Directly solid is converting into gas is only called as, what is to call, guys? Sublimation. Okay? So that is what you have to remember. Now, similar way, gas to solid also, again without forming liquid, is also called as what? Sublimation only. Do you understanding? But for this one we have another name also, we can call it as deposition. What is to call, ready? Gokul? Deposition. But if you
Vaporization.
need to remember, you can remember only sublimation. So without forming liquid is the most important thing. So if you take the solid substance, directly it needs to form what substance? It needs to form the gaseous substance. So or else it is gas to solid directly, which is we used to call it as sublimation. Is it okay, guys? Everyone, please respond.
Yes, sir.
Without forming the liquid is very, very important. So the changing of solid directly into vapor is also called as sublimation, or changing the vapor directly into the solid is also called as sublimation. But sublimation, what is the common name of a reverse process? Gas to that one is called as what? Is called as deposition. That is what you have to remember. Now, any substance, please write the definition alone and you write this equation also. So remaining and all the process, everything we'll study in the next class. So please all of you write solid to gas. That is what, heating or cooling, guys. Solid to gas, sublimation, heating or cooling. That is also very important. Heating. Do you understand? Gas to solid, it is cooling. Okay, so that is what we used to call as sublimation. So reverse gas to solid, we can say deposition. So most of them, they don't know this, then you can write it, it is correct only. So please write the definition. The changing of a solid directly into vapors on heating and vapors into solid on cooling. Vapors into solid on cooling is known as sublimation. Is it okay, Hari? Ready? Is known as sublimation. But gas to solid, what we can call it also? We can call it as, what is the perfect name? Deposition, we can say. But people used to consider both are sublimation only. Both are, we can use separately also. Solid to liquid, solid to gas, we can say sublimation. Gas to solid, we can say deposition. So ever convenient, both you can call it as sublimation only. But solid to liquid, solid to gas, it is heating, and gas to solid, what is that, guys? It is cooling. Okay, so that is what you have to remember. So this is what is sublimation, then what is the sublimate, what is sublime, that is all the things we'll study in the next class. And also what is the examples of this one and how to get that is all we'll study. So later, effects of change of pressure. So with that, effects of change of temperature will be over, and next one, effects of change of pressure we will study, and later last concept of this chapter, that is what